Alright, welcome you guys. Today we'll talk about graphing a function rule. Alright, and there's going to be two types of graphs. There's going to be a discrete graph and a continuous graph. Okay, so a continuous graph is the most normal one that we've seen so far. It is the ones where all the points are graphed. You can see everything, and no matter how much you zoom in, everything's graphed out. Now, a discrete graph, let's say I was using the same exact thing. We'd have a point here, a point here, a point here. You just wouldn't graph all the points in between, but you have enough points that you can actually see a pattern. Okay, something that looks like that. Let's say it went up there wherever. Okay, so that's a discrete graph versus a continuous graph. And once again, you're just checking your points and just working with it. And remember, go to Desmos. It is just a super helpful place to actually graph these points and everything. So something that looks like this, if it was linear, you'd be increasing on each one at the same time. So let's say we're graphing 1, 2. Then we were graphing 2, 4. Oh, need to put a comma between them. Alright, and then 3, 6. Need our comma as well. Okay, now as you can see, this is a discrete graph. It's just working like that. Okay, now if we wanted to graph a continuous graph, it would be y equals 2x. And as you can see, it actually goes through the line, and you can see what a continuation on. Okay, but let's pretend we didn't have that. What would be the next number? So you would look here on your graph. You would use the grid paper, and you would go, okay, I'm going up 2 over 1, up 2 over 1. So the next one should be 4, 8. And voila, it should be. And if you wanted to check it, you could actually check it with the actual function. And remember, if you take your function and overlay it with your discrete data, you should be able to see it and go, oh, that's where I screwed up, or that's how I made a mistake, that type of thing. Okay, and something like, let's say that we turn those off. Let's say we actually had one right here. Let's say we had y equals x squared. Okay, something like this. All right, now if we were to graph the discrete data, we would have 0, 0. Well, that works out because that's on it. We would also have 1, parentheses 1, 1. Oh, which is not on it because I put 2, 1, 1. All right, and then we should have 2, 4 with our parentheses or our dot right there. Also, we should probably go a little bit to the left, so it'd be -1, 1. Okay, and no matter whatever x value I use, I'm actually putting in the square of it because that's what I'm doing to the actual function. Okay, and as you can see, this all appears here, so I can take this off here and just go, oh, that's what it's going to look like. Now if I did a -2 to this, like if I did a -2 like that, as you can see, my discrete data doesn't match up. So what would I do? I'd just -2 from each one of these. So -2, -2, let's go -2, -2, and we -2. So you just -2 from each one of those. It's really kind of cool how it works to where you can actually make the data manipulate so that you can actually work to it. Okay? Alright, but that's pretty much it. Basically, it's going to be taking a lot of plugging in and just working with it. You do have to take your time and just think about, okay, what am I doing? How am I graphing this? What points am I getting? So if you were to start out with a function like y equals x to the 4th -3, you would need to do a table of values, and you could set it up in here in Desmos and just look at it and go, oh, okay, there's my points that I'm working with. Or you can actually plug in some other points. You could go in here, you could press enter, and I can enter a point in between -1 and -2. I could go -1.5, and as you can see, it's the number between. Okay. Now some interesting things are too is that I could keep putting in data, so -1.25. Okay, and as you can see, my number gets closer to 0. Okay, and that's an interesting part. So let's go negative 1.1. Okay, and as you can see, I've already passed it, so I should probably go back here to negative 1.3. Okay, when I go from a positive number to a negative number, I had to cross somewhere, and here's an interesting fact. I've actually crossed at the answer to this equation. Okay, and you can actually click there and actually see what it's going to be. So if I plug it in, negative 1.316. Okay, that's going to be a really small number. And anything to this number is going to be, that's scientific notation, so that's going to be about 4 decimal places to the left still. Okay, so that's going to be really close to 0. So it's just really kind of cool to see how a table can actually help you graph this stuff. Okay. Alright, that's it for today, and I will talk to you guys later. If you have any questions, please feel free to call me or email me. Okay, thank you. Bye.